Let's solve this example to connect back to our work on constant speed or constant rate of change that we studied last time. Wesley walks at a constant speed from his house to school, which is 1.5 miles away. It took him 25 minutes to get to school. The first thing we would like to find out is what fraction represents his constant speed, which we are denoting by the letter capital C. Let's remember that speed is distance divided by time, in particular, the distance it takes to travel a certain amount of time. And that calculation should be done as an average in these cases. So I'm going to take C, which equals 1.5 miles divided by the 25 minutes it took Wesley to walk. Now I could adjust this to write it as a fraction without any decimals by multiplying the numerator and denominator by 2, and that obtains the equivalent fraction 3 divided by 50, 3/50 miles per minute. Next, let's look at the second part. You want to know how many miles Wesley has walked after 15 minutes. So let's bracket that. How many miles he's walked after 15 minutes is the question that we are answering. So we're going to let y represent the distance he has traveled after 15 minutes of walking at this given constant speed. What fraction represents that constant speed in terms of y? Well, we expect the speed to be the same, because it was constant, as what we obtained in the earlier problem. For that reason, I can use the letter C again here. And I'm going to set that equal to y, whatever distance I traveled, divided by the speed, 15 minutes, that we know he has gone. In the next part, we're going to take this information together to set up a proportion to solve and find out how many miles Wesley walked after 15 minutes. To do this, we might set up a table like we have in the past, where we have time versus distance and record the information that we know. We know that in 25 minutes, Wesley could walk 1.5 miles at this constant rate, and that in 15 minutes, we are using the letter y to represent the distance he could walk. That allows us to set up a proportion. The y divided by 15 from part B equal to the 3/50, which was our simplified fraction that we found in part A. And I'm going to note that we have miles in the numerators of both of these fractions, divided by minutes in both of them. So these are two speed calculations that have been set equal to each other because we are told we are walking at a constant speed. Now, let's review where we have gone so far. We set up a proportion. In order to find out what this distance is Wesley's traveled, we're going to need to cross multiply. That's always our next step. And lastly, we're going to solve that new linear equation that we obtain from doing that cross multiplication. So I'm going to circle in yellow here. I'm cross multiplying the y times 50, the numerator of the left times the denominator of the right. 50y equals, let's change colors. We're doing the other cross multiplication, the 3 numerator from the right times the 15 denominator from the left, so we get 3 times 15, or 50y equals 45. To solve this equation, I'm going to take y and set that equal to 45 divided by 50, which I can reduce to the fraction 9/10 miles. So let's go on and look at the last part. Let y be the distance in miles that Wesley traveled after X minutes. Now, I want to point out this is a different y than in the previous part of the problem. We can now think of the y we used in C as being known as 9/10 or 0 and 9/10 miles. So what we're asked to do here is to write an equation in two variables that represents how many miles Wesley walked after X minutes. I'm going to set up a proportion, y divided by x must be equal to the 1.5 miles divided by the 25 minutes. It's this third row I've put in my table. Let's proceed by solving our proportion. And we're going to use the same steps as before. We need to do a cross multiplication of y times 25. And we get 25y. We set that equal to the product in the other direction of x times the 1.5. 1 and 5/10 x. Because we want to know how many miles Wesley walked after X minutes. So we need to get the y by itself. Therefore, I divide both sides of my equation by the coefficient 25 on y to obtain that y equals 1 and 5/10 divided by 25x. And notice that's a calculation in miles. I can reduce it to the fraction 3/50 x if I don't want to combine decimals and fractions. And in this way, we can answer y equals 3/50 x as being that linear equation in two variables that solves our problem.